Hello students, myself Dr.B.Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now, we are going to discuss about the overview of system design in fiber optic communication system. Let us see the analog system design. Let us consider system design. If any optical communication system, we know that here optical signal is converted into a light signal and we can transfer over a longer distance through the optical fiber. At last, we can recover the signal, we can convert the signal from light signal to electrical signal by using the photodiode. Finally, we can get the signal. So, why we can go for this conversion? Why we can go for this optical fiber? That is very important here, because once we convert the electrical signal into light signal, we know that the speed of light is 3 into 10 power 8 meter per second. The speed of light is very fast. That's why we can convert the normal electrical signal into light signal, and this light signal can be fed into the optical fiber and we can transmit. So, if we use a light signal, what will happen? The data rate will be high. That is very important in optical fiber communication system. Is data rate is very high here. That's why, so we can use optical fiber communication system rather than conventional system. Fine. Now, while designing an optical fiber system, so we have to consider all the parameters. Fine. Let us see. Suppose, so if you consider the system design, the designer has to think the several iteration, because here while transmitting the light signal, so we need amplifier. So, n stage of amplifier required. So, this is one of the important point. Next one is, after that the light signal can be converted into the electrical signal. So, we have to see the photodiode operating characteristics. So, while designing a system, optical fiber system, so we have to consider the fiber characteristics, source and the photodiode characteristics also. Also, for analyze the system, so we need several iteration, n number of stages required for satisfy the system design. Next one, here cost constraints. Cost constraints is one of the important factor in analog system design, because here the cost of the fibers is all are cost effective. So, we have to see the cost constraints also while designing a fiber optic communication system. Another one, here a designer must be carefully choose the component to ensure the desired performance. So, whatever performance required, so in such a way that designer has to choose the particular component, so that should be coupled with the another device. That is, the characteristics will be coupled with another device. That is important point while choosing a system. So, here first one is it required several iterations and cost constraints, and after that choosing of the components for a system design. So, these are the three major important factor while designer think while before designing a system. Fine. Now, let us see the analog system design. So, as I said earlier, so here the electrical analog signal, and then we can convert the electrical signal into the light signal, and optical transmitter is the one we can transmit the optical signal, so through the optical fiber, and next here this is the fiber channel. Okay, so here we can use as amplification. Next here optical amplifier we are using. Finally, by using the photodiode, so we can recover the light signal into electrical signal. Okay, so see here at the output electrical analog output signal to RF receiver. See, the input is electrical analog input signal, output also electrical analog output. Okay, so this is the one. So, now the thing is that input output both are electrical. The main thing is, the important parameter is, here we are converting, in between we are converting the electrical to optical, again optical to electrical, because of data rate requirement. That's why you can go for optical fiber communication system, as I said earlier. So, while choosing this system. So these are the constraints are there. So we should take care, designer should take care to overcome this all the problems. So let us see one by one. See, if I convert the electrical signal to optical signal, so in the optical transmitter region, that area, so we are feeling, so these are the drawbacks present in the optical transmitter side. So designer has to take care of all the things and have to recover, they have to minimize this effect. That is very important here. So now first one is harmonic distortion, intermodulation, relative intensity noise and laser clipping. So these are the major problem occurs in the optical transmitter. Generally, so these are the problems will occurs in the optical transmitter. So we should overcome this all this effect. That is important here. Okay. See, this under all are the problems only here. So each and every stage, what are the problems we are facing in the system? Okay. So that only we are going to discuss now. Okay. Fine. So the harmonic distortion, signal variations. Signal variation with respect to the input voltage. So what will happen? The distortion will occur. So this also you should take care. Next, intermodulation. So generally we can use a modulation. So here that problem will occur. Then relative intensity noise, because we are converting the light signal, some intensity noise will occur. Some clipping also happen, because laser clipping also happen here, because here some clipping occurs in the laser light signal. Okay. So these are the problems in the optical transmitter side. So designer has to think and he should minimize this all the effects. Fine. Next one, optical fiber channel. So in optical fiber channel, so we are facing these problems. Generally in channel we are facing the noise. Generally in optical fiber communication system we are facing a noise. But here the main thing in this optical fiber communication system, here modal distortion, intermodal distortion. Okay. So here what will happen? A signal. Okay. So it's transmit in form of pulses. Okay. So what will happen? So here this aliasing happen. So due to a timing inaccuracy, so what will happen? Aliasing will occur. Okay. So that's why we should avoid this one. So this is modal distortion will occur. And next, attenuation. So we know that here the attenuation mechanism, here the scattering, bending loss, absorption loss. So these are the major drawbacks we are seeing only in this fiber channel only, fiber area only. Next one, group velocity distortion. Okay. So this all we should minimize in the optical fiber channel. Next, coming to the optical amplifier, because we should use n number of amplifiers to increase the gain of the light signal. N number of optical amplifiers we can use to increase the gain of the amplifier. So here the main thing here, AC. So this noise will occur. Okay. So optical amplifier noise. So this optical amplifier noise will occur in this region. Okay. So this we should minimize. This you should minimize. Okay. So generally here optical transmitter, some list are given. So these are the problems in occurs in the optical transmitter. This you should minimize. Similarly in optical fiber channel, so here some distortion will occur, we should minimize. Similarly in the optical amplifier, some noises will occur, that we should minimize. Okay. So now optical detector. In optical detector, so we have some noises are there. Okay. In the detection side, again we are converting the light signal to the electrical signal. So now here generally we have some short noise, thermal noise, amplifier noise, avalanche photodiode noise. So some noises will occurs, okay, in the receiver side. Okay. So that because the light signal converted to optical signal, light signal converted to electrical signal, some noises will occur. Okay. So here the main thing, once again I am saying, while choosing this system, a designer has to carefully see all the constraints and they should minimize all the effects. So, this is analog system. Now, point to point link. Point to point link. Here, if you see the point to point link, we know that generally in optical fiber communication system, here a optical transmitter, a receiver is there, in between the optical fibers are there, and you can use a n number of amplifiers we are using. So, the main thing in the point to point link, so we have to see, so the designer has to see the constraints, see the conditions. Suppose in fiber type, anyway in optical fiber communication I am using the optical fiber, that is compulsory. Okay. So, while choosing a fiber also a major condition, major problem here. Okay. So, whether we should use multi-mode fiber or a single mode fiber depends upon the applications. So, we can choose the fiber. So, designer has to carefully think and they can choose the fiber according to the needs. Okay. So, suppose if you use multi-mode or single mode fiber, so mainly we can see the core size and the core refractive index profile, bandwidth or dispersion, attenuation, numerical aperture or mode field diameter. Okay. So, even anyway we are using fiber here, but in the fiber also we have to see all the constraints, all the characteristics, core size, refractive index profile and bandwidth, and how to minimize the attenuation and good numerical aperture. This they should consider. Okay, fine. Now, if we choose a source, optical source, we know that generally optical sources are LED or laser diode are the two major optical sources. Okay. So, even if we choose laser or LED, okay, so we have to consider this all the points. So, emission wavelength, spectral line width, what is the output power gain and effective radiating area, how much it can cover, emission pattern of the light rays and the number of emitting mode. Okay. So, these are the points we should consider whether if we choose either LED or laser, we should see all the things: wavelength, spectral line width, output power and radiating area, emission pattern as well as the number of emitting modes. Fine. Now, at last, pin diode or avalanche photodiode. Okay, either if you use pin or avalanche, whatever it may be the case. So, we can see the responsivity, that is very important point. Okay, so how it is response, that is very important here. Okay, how the light signal is connected to the electrical signal. Okay, how much the response rate and the operating wavelength and how much speed of conversion and sensitivity. Even a small amount of information also it can be able to sense and convert into electrical signal. Okay. So, a designer has to think the fiber, sources and diode, okay, and you have to see all the characteristics and we should see everything while designing a system. Thank you.